So far in chapter 8, we've learned how to do hypothesis tests, and we applied that to proportions and means. So next up leaves standard deviation. Before I get into the testing of hypothesis with a standard deviation, let me remind you what the standard deviation is. In fact, can anyone tell me what the standard deviation says about a data set or a probability distribution?
How spread apart it is.
Yeah, thank you, Jalen. How spread apart it is, how spread out the data is from the mean. Now, the link that I sent you takes you to a web page like this. It's a Desmos web page. And let's look at a couple different things about this curve here. Now, what's this curve look like? What shape does it have?
A bell.
Yeah, a bell shape, a normal distribution, right? Now, there's a couple different things you can change with respect to this, and it'll change the look of this distribution. One of them is you can change the mean of this distribution. So that's the M bar right here. And you can slide this around left and right, and that'll change where the distribution is located. But it doesn't change how spread out the distribution is. That's done by changing the standard deviation. So if I increase the standard deviation, I should increase the spread of the data. So let me do that. There you go, and you get a flatter and flatter curve. But on the flip side of things, if you decrease the standard deviation, then that curve has more of a pronounced hump or spike. And so this gives rise to a term that maybe you've heard in the media with regard to the coronavirus, and that is flatten the curve. The idea is that at some point, a hospital is going to reach its capacity to deal with patients. So we can adjust this little y equals line to be anything you want. But at some point, unless you spread out the curve, then our curve is going to crash through the hospital's capacity to treat patients. And this is happening right now in several rural areas of our state where the capacity to treat people isn't meeting the need. So it's kind of a big problem. And I hate to tell you this, but do you know what age demographic is driving this spike in cases right now? We're at 3 times what we were a month ago in terms of number of cases, and our positivity rate's gone through the roof. Any guesses? What age group is driving this?
Probably 20s.
Yeah. It's the 10 to 19 and then the early 20s. Yeah, that's what's driving it. So I think Anthony Fauci said it best. He goes, you don't spike the ball when you're at the 5-yard line. We're almost there. I just got my first vaccine yesterday, so it was kind of neat. Happy about that. But I encourage you not to, ease up on your good habits too early, because everybody knows somebody who's had problems with coronavirus, and in particular, one good friend of mine, he got over the disease a month ago, but he still doesn't have a sense of smell, and he can barely taste anything. So it's just not just like a bad flu. It has some other really bad effects. So
I volunteer at vaccine clinics, and there's people coming in that had it, and they had it like 7 months ago, and they still don't have their like taste or smell back.
that's
They're
just
still, yeah.
awful. I mean, I really like food. I do. I cook a lot of fun things. I make my own beer. And if I couldn't taste, wow, that would really suck. So
Yeah, they said it affected their mental health like a lot, which understandably so, but I don't know. I feel like that should just give people an idea, just to you can stay in your house for 1 to 4 more months isn't gonna change anything, and then everything could be finished and we could just be back to normal.
Well, I appreciate you speaking out, and I hope that people take this message to heart, because it's getting really bad in Michigan again. And
Right.
I'd hate to see us have to shut things down, et cetera, especially when we're almost there. But in any case, I took this little venture in part to raise awareness, but also to remind you what the standard deviation is. It's how spread out the data is. And that's what we're going to be testing in section 8.4. So any other comments on our little sidebar before we dive into hypothesis testing for section 8.4? Okay, so hopefully you got this handout on hypothesis testing for population standard deviation. There's going to be some things about this that we can't control too easily. And the first one of which, the assumption is that you have a simple random sample. I don't think the stat lab is really going to say much about this, and many of the problems, it's just something that you have to assume. The one thing that we can do something about is this requirement. That is, the population has to have a normal distribution. Now, there's a couple ways you can check this. You can check it through the Explore Data option in StatDisk, or you can just do normality assessment. Both of them will give you a histogram and normal quantile plot. The problem with this test is that it's very sensitive to having a normal distribution. This is not like testing a population mean where you can kind of wink and nod a little bit at the requirements of normality. Here, it's really imperative that you have to have a normal distribution. So just giving that to you as an FYI, we're not actually going to be spending our time testing this, but it is just a little heads up. As far as the test itself, it's going to be based on a chi-squared. We're not really going to see that too much because we're going to follow along the steps that we did with testing a hypothesis for a proportion and a mean. The state the null alternative hypothesis, decide on alpha, and then enter our data into StatDisk. That's going to be our third step. Now, it used to be for me that we'd end up finding critical values. That was old school before we had better technology available. Step 4 is find a p-value. Step 5, if your p-value is less than alpha, reject. And then step 6 is state your conclusion in words. So I'm keeping these steps consistent so that you can get in a rhythm, because we're going to do a lot more hypothesis testing. It's going to be what we're going to be doing the rest of the course. So I'm hoping that you'll catch a groove based on this. Let's get started with some of the examples. So we'll start with this one. Now, the challenges you're going to run into is figuring out what everything is. So I'll help you out on this one and maybe one more. Then by the time we get to the third example, I'll let you try it in some small groups. For this first one, the piston diameter of a certain hand pump is 0.7 inches. The manager determines that the diameters are normally distributed with a mean of 0.7 inch and a standard deviation of 0.003 inches. After recalibrating the production machine, the manager randomly selects 23 pistons and determines that the standard deviation is 0.0022 inches. Is there evidence for the manager to conclude that the standard deviation is decreased at the alpha's 0.10 significance level? Wow, there's a lot going on here. Let's refresh our memory as to all of what we need. So the first thing that we need is to figure out the null and alternative hypothesis. And that's not necessarily very easy for this one, because there's just a lot of numbers and we have to think carefully about what's what. But they did ask us at the end here if there's evidence to conclude that the standard deviation has decreased. Well, one thing for sure is that that's a big hint that you're testing this claim, something about a standard deviation. The other thing is that we're looking to see if it's decreased. So that means whatever the standard deviation is, it's less than it was. So that's kind of a clue there. It's decreased from what? What value was it that it decreased from?
0.003 inches.
Ah, well done. Thank you so much, Don. Yeah, as it decreased from what it was, which was the 0.003 inches. Perfect. So that's our original claim here. Let's go over here. Is that going to be part of a null or alternative hypothesis?
That's all alternatives.
Good. That's your alternative hypothesis. So for our null hypothesis, what would we put there? So we got sigma is less than 0.003. What's in the null hypothesis?
Equal.
Yeah. So what I generally have you guys do is write just kind of exactly the opposite, but I think you've seen it in Stat Lab often enough that they're not exactly fond of that. They'll write sigma equals 0.003. So when you do your homework, you'll get something like this. You get a little pull down box. You have to choose the correct parameter. And then another box asking you to choose the correct symbol. And you have to do that for both your null and alternative hypothesis. So just giving you a little heads up on something like that. Okay, so that's step one. Step two. Who picked up on what alpha was?
0.10.
Awesome, thank you. 0.10. And so that takes us to step three. In step three, let me just write down a few of the things that I think that I'll need to know. And I'll need to know N, and I'll need to know S. So you're gonna have to look through this problem carefully and decide, well, what information do I need to know? Okay. I need to know N and S. Can anyone give me either of those values?
N is 23.
N is 23, good. How about S? What am I gonna use for S?
0.0022.
Yeah, exactly, right here. 0.0022. And so that takes us to step four, which is to find a p-value. Of course, we got to plug this into StatDisk first to find that p-value. So let me go up to here. Confidence level. Let's see, no. How about if I go to analysis and then hypothesis testing? Which one of these 7 do I want?
Standard deviation, 1 sample.
Thank you, Kelly. Standard deviation, 1 sample. Now we're going to use summary statistics, meaning we already have any means, ends, standard deviations that we need. So we're good there. Alternative hypothesis. Which one of these 3 do I want? The not equal to, the greater than, or the less than?
Less than.
3.
3. Our significance level is not 0.05, although that it's a very common one. What significance level are we using in this case?
0.10.
0.10, well done. The claimed standard deviation, that's something that comes from your null hypothesis. So here was our original claim. In fact, I should probably circle that. We're going to need to refer back to that as our original claim. But what you should get out of that, though, from your null hypothesis is the claimed standard deviation, which is 0.003 of an inch. It's really small. The sample size was 23. The sample standard deviation was 0.0022. And bam. All right. What information is it that I need from this particular step?
The p-value.
Good, the p-value. So the p-value is 0.03923. So thank you for that. that takes us to step 5. Step 5. What do we do in step 5? Does anyone remember?
Reject or fail to reject.
Yeah, thank you, Kelly. Reject or fail to reject. So someone help out in this situation. Are we going to reject or fail to reject?
Reject.
Yeah, reject. If P is less than alpha, reject H naught. And I'm most happy if you put reject H naught rather than just reject, because I've seen some people reject HA. That's not true. All our decisions about hypothesis are based on the null hypothesis. You accept it, or you fail to reject it, or you reject it. Finally, step 6, we got to state our conclusion in words. So let me go back to that handout that I gave you from section 8.2, and I'll clean this up a little bit. Here's where we need to know what the original claim was. So look back. This was our original claim. Does the original claim contain the condition of equality? Yes or no?
No.
No. It had a less than. Did we reject H naught?
We
Yeah.
did.
Yes. So that brings you to C. And the wording of the conclusions should start with this right here. The sample data support the claim that. So I'm going to copy that down here for myself. The sample data support the claim that. Now to fill in the rest of this with words and not symbols, I don't want sigmas less than 0.0003. To fill in the rest of this, go back to the original problem. So that was here in section 8.4. To conclude that the standard deviation has decreased. Standard deviation has decreased. You could also say is less than 0.03 or 003 is an alternative, or is less than 0.003 inches. And I don't mind this either. I kind of like it because it tells you what it's decreased from or what it's less than. But in one way or another, I need you to communicate your solution in words, not in symbols. How are we looking on that first example? Okay with
Good.
that? Doing pretty good. So just like our test for population mean and population proportion, 6 steps, go through them all. If this were a face-to-face class, I'd probably give these the following point values. The first one is worth 4 points because 2 of the points are just for choosing the correct symbol. Sometimes people use an S here. That's wrong. You're always going to put a population parameter. It's going to be something like this. And the other part is for getting these symbols in the right direction. So 2 points and another 2 points. I don't award any points for step 2, but for step 3, maybe a couple points, depending on how I can manage it. A point here, and then 2 points here, another 4 points there. So if that gives you an idea of the relative importance of each step, that's good. But definitely, I put a big emphasis here. And even this part, you want to get that part right, because without this, then you're going to miss this. So this has a potential to really cost you 6 points, depending on what happens. let's try
I have
another one.
I have
Yeah,
a quick question.
Yeah, please.
So for example A, like I'm looking at the handout and where it says calculate the value of the test statistic, the value they have is 13.5, but when I'm looking on StatDisk, it's
We
like
got the
11.
different value.
Oh,
Yes.
okay.
Yeah. Now, I ran into that in my morning class, and I probably should have said something as a, a warning or a heads up. But yeah, we got something different than on a stat disk than what they got. So the only thing I can think of is that sometimes when I do these problems and I select them for us to use in class, I'll pull up a problem and then I'll advance to the next problem. And then I'm like, oh, you know what? Let me go back and do something for my students. And so when I do that, it actually changes up the numbers. And so the only thing I can think of is that it changed up the numbers when I went back and copied it. Because I don't know. I mean, I think you and everyone else probably got this test statistic and this chi-square value and this p-value, right?
Yeah.
Did you guys match me on that?
Even in the homework, I tried to do it before the class. Like
Mhm.
one of the problem, I did the step exactly, and it still give me different numbers. So the answer is always going to be wrong in the homework. I think number 5 or 6. When we have to use the data, it still give me. I try exactly the same steps, and it's give me wrong answer. So it doesn't matter what you do; it's going to be wrong answer.
I hope not. Tell you what.
Well,
Here's problem number 5. Let's do problem number 5. Okay, so the null hypothesis.
I'm talking about the one has the data, like you have to copy the data.
Okay, so all right, which one is it that has the data?
I don't remember, 5 or 6, one of them.
Let me try 6. No, 6 doesn't have data. We are going to do one like 6. It's kind of neat. It's an application of statistics to mutual funds.
Maybe 4. I don't know.
Inshallah. Yeah, here we go. All right, so let's do 4 then. Okay, and let's see what happens. The data show that men between the ages of 20 and 29 in the general population have a mean height of 69.3 inches with a standard deviation of 2.4 inches. A baseball analyst wonders whether the standard deviation of heights for Major League Baseball players is less than 2.4 inches. Okay. So let's see here. Heights of 20 randomly selected players are shown in the table. I'll tell you what, let me see if I can't grab these and copy them and send them to you guys in the chat. That way everyone's working with the same data set. Because if you did your own data set, then you're going to end up with different numbers. All right, so that data set come through in the chat. I'll take that as a yes.
Yes.
Thank you. Now on StatDisk, if you're going to enter your data, you can click the StatDisk Online icon in the upper left-hand corner. That should take you to the sample editor. If you have stuff there, like I do already, you can clear it out and then copy and paste in everything else you need. So there's my values. Now there's a couple ways I suppose I could work this. I could work this with the, I could get some sample statistics Right here, I could do explore data and get sample statistics. So column 1, like that. Then I've got all my sample statistics. The benefit here is that I can see, you know, this may or may not be normal. It doesn't look great. It doesn't look horrible either. You can take a look at the box plot down here. You can see it's not quite symmetric. A little bit more of kind of an outlier here to the right. The normal quantile plot, you know, okay. But let's just move beyond that part. I mean, you really should be testing. In fact, I guess since I've got data here, let me go one more step here. Let's do a normality assessment. Here's what you're looking for. Failed to reject normality. Basically, this data set didn't prove itself bad enough that we can reject the assumption that this is a normal distribution. If you remember from the handout, one of the assumptions that we need, or the requirements, is that you have to have normally distributed data. And we can't prove that we don't have normally distributed data, is what this is saying. So we're okay there. We can do with the rest of our test. So I can close this out. Baseball analyst wonders whether the standard deviation of heights of major league players is less than 2.4 inches. So that's actually an alternative hypothesis, that sigma is less than 2.4. What does that mean? I'm going to put in the null hypothesis.
Sigma is greater than or equal to 2.4.
Yeah, sigma is greater than or equal to 2.4. So first we'll choose sigma, but it doesn't let me choose greater than or equal to. So what should I choose?
Equal?
Equal to.
Yeah, equal to. So we'll choose equal to, and then check answer. Yay, thank you, nice work. We got to calculate a chi-square value. So, all right, let me copy down a couple of things here. Sigma equals 2.4. And then sigma is less than 2.4. Step 2. Did they tell us alpha? No, they didn't tell us alpha. So what value of alpha do you think we should use? I'd say 0.005.
Yes,
Yeah, 0.05. That's a good one. The other standard one, a little bit higher to reach, is 0.01. But those are the two that you're typically getting. Oh, there you go, 0.01. All right. Thank you. Perfect. I didn't look far enough. You're right. Right down here, alpha is 0.01. Good job. Step 3 was to enter the data. We did that. So step 4, we got to obtain our chi-square value, and from that we can get a p-value. So this is where I'm going to hold my breath. Hope that all works out good. Let's go to analysis, hypothesis testing, and then down to standard deviation 1 sample. So once again, it's analysis, hypothesis testing, standard deviation 1 sample. We're good there? Before I start making changes here, there's one change I need to make up at the top. Does anyone know what that would be?
Use data.
Yeah, we're going to click use data so that we're using the data that we input rather than something else. Now, the alternative hypothesis is that our population standard deviation is less than 2.4, so it's less than the claimed amount. So I'll use that third one there. The significance level is 0.10. Not trusting that went in right, 0.10. The claimed standard deviation was 2.4. I'm going to use column 1 for our work.
I thought it was 0.01.
You're right. It is 0.01. My bad. 0.01. Okay. So I think the number we needed to get out of this was our chi-square value was 13.98. And our p-value is 0.2154. So let's see what we need to do.
15.09. I don't know why. I'm sure I put the same data you did.
Really?
Yes.
So you got a chi-square of 15? Did anyone
I
else get a
did.
chi-square of
Yeah, it's
15?
been like 15 minutes in this problem and it still give me wrong answer.
Let me hear from other people. Are you guys getting a different chi-square value than me?
No.
No, I got 13.98.
Are you using StatDisk online or did you download the program to your laptop? Madeja?
Yes, I use the same exactly StatDisk online.
Your StatDisk online?
Well, I'm gonna keep trying after the class.
Okay. One last thing to check. Do you have 20 data values in column 1? Does your data set go down to 20?
Yes.
Boy. I've kind of
It's
run out of.
okay. Maybe something in my computer. I will try like from different site later.
Okay. Well, I'll be happy to try and help you out as well. So,
Thank you.
Yes. 13.98. I'm going to copy that and let's see if I can't find our problem now. Come on. Warm up again. There we go. Round to 3 decimal places as needed. So there'd be 13.984. I don't know. It likes me. I'm not sure what it's like. Why it's not working for you, Madeja. Yeah, that's just strange. The p-value.
Oh, my problem is say 3.2, not 2.4. I don't know how it is. Maybe I get different.
Oh, well, yeah. Okay.
Homework
So,
yes,
so
it's the same problem, but it's still me. The Std Dev is 3.2. Maybe
every
that's
time
why.
every time you do this, it's going to generate new numbers for you to work with. So yeah, if you're not working with exactly the same numbers, null and alternative hypothesis, you're going to get different results. So maybe that's part of what's going on here. Is that
Okay, I will
yeah.
do it later. I didn't want to waste like last time. Thank you so much anyway.
Yeah, you're welcome. All right, so step 4 gave us our p-value. What's step 5? Somebody I haven't heard from yet today.
Reject or do not reject.
Thank you. Reject or don't reject. And maybe your sister can answer. Should we reject or don't reject?
I think you do not reject.
Good. Fail to reject H naught. Because our p-value is greater than alpha. Greater than alpha. If the p-value is high, H naught will fly, meaning we'll let it go. We'll let it fly. We won't reject it. So that takes us to step 6. And for step 6, you know what? I forgot to circle my original claim again. Which one of these was my original claim?
The alternative.
Yeah, the alternative. Way to go. So sometimes I think of it as my original claim. Sometimes I think of it as the orange claim. Either way, the alternative does not contain the possibility of equality. Let's take that back to our step 6 from our handout on wording the hypothesis conclusion. Does the original claim contain the condition of equality? No. Did we reject? No again. So that brings us down to step D here. There's not sufficient sample evidence to support the claim that, and so right now I'm just going to copy that stuff down. Stuff in D. There's not sufficient sample evidence to support the claim that and now we need to turn back to the problem itself to see if we can't figure out what that claim was. B. Actually, you know what? We kind of extemporized on that one. That one was right here. The standard deviation of heights of Major League Baseball players is less than 2.4 inches. I know it's a little wordy, but we need to write it out as is. The standard deviation of heights of Major League Baseball players. I'm just going to write MLB players, make it a little bit more palatable, is less than 2.4 inches. Nice. Okay. Are you comfortable with our conclusion and the way we worded our conclusion? Like I said, to me, that's worth about a third of the points for a problem like this. Let me just summarize it because this example had a few tangents on it and took a little bit longer. So let's go back and recap this one, and then I'll give you one to try. So as far as a recap is concerned, here was the original problem, and we can see that we're testing a claim about a standard deviation, all right? And the claim that they're testing is that the standard deviation of heights of Major League Baseball players is less than 2.4 inches. So that gave us our original claim. Right here. That's your original claim, so that puts this here. Now we took the data that they gave us in this problem and we actually analyzed it. Because when you're looking at this kind of a hypothesis test, one of the very important things is that you have to check and make sure that the data is normally distributed. That's circled here in purple. So we took time to do that. You can do that by going to data, a normality assessment. If you just want something nice and quick and clean, column 1. Or you can do explore data. Explore data is going to give you some of this stuff as well. But the nice thing here is it says, yeah, we're not going to be able to reject the claim that this is from a normal distribution at either of these levels. So you did your due diligence. You satisfied the check that your data is from a normal distribution. So then we move on to input our data. So that's step 3. I'm skipping step 2, which was alpha's 0.01. They gave it to us. We input our data in StatDisk, and we got this chi-square statistic and that p-value. Now that p-value is bigger than alpha, so that means you fail to reject your null hypothesis. And then the last thing is to figure out how you state the null hypothesis, state your conclusion. And we did that with help from our wording the hypothesis conclusion by deciding which path we followed. It was a no and then another no. So that brought us down to option D. Nice. Okay. Your turn for one, unless there's some more comments or questions on this one. So B. Oh, no wonder why I wasn't finding something that I wanted. I was in the wrong section. Here we go. So this one's kind of a nice one. It's a nice application towards finance and economics. The risk of owning a mutual fund. A mutual fund, in case you're not familiar with them, this is like a group of stocks. Stocks are investments in companies. And what you do is you buy a little share of that company and you hope that the company does well and its stock price goes up. If it does, you make some money. Mutual funds try and reduce the risk of owning one stock by owning a lot of stocks. And as a measure of how much risk a particular mutual fund is, you look at the standard deviation of its monthly return rate. So the higher it is, the more risky it is, because there's more volatility or fluctuation in its price. So I'm gonna let you work in problem D for a little bit. I'll put you in groups and then we'll come back here and share our answers. Recording. So we noted that this was kind of the statement that we're going to test. That is, the standard deviation of monthly return is less than 3%. Is that part of the null or alternative hypothesis? Someone from group 1A, please.
Alternative.
Good, that's the alternative. So group 1B, if this is the alternative, what's in the null hypothesis?
Sigma is greater than or equal to 0.03.
Perfect. Thank you, Don. Sigma is greater than or equal to 0.03. Now keep in mind that when you enter this into StatDisk, there's not StatDisk, but into my stat lab, they're going to use sigma equals 0.03. It's okay, small difference. Step 2, they gave you that sigma or alpha was 0.10. For step 3, I just wrote down a couple summary statistics for myself that comes from the problem itself. So the standard deviation rate of the 23 months of data turned out to be 2.68%. And over here is your 23 months. So I just wrote down those two pieces of information. And we're going to take and put those into StatDisk. So here we go. Adjust your alternative hypothesis. Third one is correct. Standard deviation is less than a claimed amount. That claimed amount is 0.03. The significance level is 0.10, kind of high. Sample size of 23. And the sample standard deviation, that's stuff that I wrote down, N and S. When you evaluate that, that's going to tell you your test statistic and your p-value. The p-value is what I want. So that's what I copied down here. P-value is 0.26809. Why did I fail to reject? Why didn't I just reject? Maybe I should get rid of the fail to. Anyone from group 2A? How about group 2B? Someone there? How come we fail to reject here?
The p-value is bigger than alpha.
Yeah, p-value is bigger than alpha. Perfect, that's it. P is greater than alpha. So you fail to reject. Now for step 6, that takes us to our wording the hypothesis conclusion handout. Does the original claim contain the condition of equality? Yeah, it doesn't. So that's our original claim. Doesn't contain the condition of equality, so we branch down. Did we reject H naught? Well, we failed to reject H naught, so the answer is no. So we branch down again. There's not sufficient sample evidence to support the claim that, and then you've got to state in words some version of what that original claim was. In this case, the standard deviation rate of return, standard standard deviation of its monthly rate of return is less than 3%. Now, I didn't use exactly that stuff, but I have something that's in the same spirit. That the monthly rate of return has a standard deviation less than 0.03. Saying the same thing. Whew. How are we doing there? Are you comfortable with that one?
Yeah.
All right. All right, I'm going to stop things here. And
Can I
we'll
just
take a
see
roll.
what you put into stat disk one more time?
Sure. Let me go back here. And there's what we put into stat disk.
All right, thank you.
Mm-hmm.